Okay, everyone, let's continue looking at Module 26209-23, Grounding and Bonding, in the NCCER 11th edition. This will be Section 6.00, Testing for Effective Grounds. An earth ground resistance tester is used to test soil resistivity and to measure resistance between the grounding electrode and the earth. An earth ground is commonly used as an electrical conductor for system returns. Connections to the earth can be made using one or more grounding electrodes, a ground grid, or a ground mat. A good grounding system limits system ground resistance to an acceptable low value. Grounding systems protect both people and equipment. Ground testing also provides information for equipment installation ratings. Warning: ground resistant testers can be hazardous to both equipment and personnel if improperly used. Always check with your supervisor before using a ground resistance tester. The fall of potential method measures earth resistance by passing current through the earth between electrodes. The voltage drop between the electrodes is measured and then used to calculate resistance. The following problems may arise with the fall of potential method. Natural currents in the soil caused by electrolytic action can cause the voltmeter to read either high or low depending on polarity. Induced currents in the soil instrument or electrical leads can cause vibration of the meter pointer, interfering with readability. Resistance in the auxiliary electrode and electrical leads can introduce error into the voltmeter reading. This figure shows a ground tester with a current supply circuit. The ground tester produces a current that passes through the earth between electrodes X and 2. The battery energizes the coil of vibrator V, which oscillates, producing an AC current in the primary and secondary coils. The current in the earth between the grounding electrode X and auxiliary current electrodes 2 creates a voltage drop due to the earth's resistance. Voltage drop causes a current in the voltmeter circuit through balanced resistors R2 and R3. Current induced in the earth by power lines are rejected by most ground resistors or testers. Earth electrode resistance. 3 components contribute to the resistance of a grounding system: resistance of the conductor connecting the ground electrode, contact resistance between the ground electrode and the soil, and resistance of the body of earth immediately surrounding the electrode. To properly measure ground resistance, the ground tester electrodes must be spaced sufficiently. An auxiliary electrode distance chart can be used to determine proper electrode placement distance. And here are some trade terms to read over and become familiar with for this section. And some review questions for this section. If the voltage drop between a grounding electrode and an auxiliary potential electrode is 10 volts and a current of 10 amps is passed between an auxiliary current electrode and the grounding electrode, then the resistance is 1 ohm, 10 ohms, 100 ohms, or 1000 ohms. That would be 1 ohm. When completing a 3-point test, the potential electrode is placed at 31% of the current electrode distance from the grounding electrode, 45%, 62%, or 74%. That would be C, 62% of the current electrode distance from the grounding electrode. All right, guys, that was it for that section. Next will be a review for the test coming up, and we'll do that in the classroom. I'll see you there.